Hello everyone, welcome to my next tutorial 1.5.1 Optimization, Analysis and Parameter Extraction. In this video, we will be show how to optimize the any layer in order to any targets. So I will consider at here emissive layer and maximize according to the target radiance. So basically I want to say in here we will be see how to we can use optimization analysis tool. So before start of my tutorial, I want to tell about myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Our company also have partnership with Nano Academic Technology, which offers several softwares like NanoDecal. It is used for the material and device simulations. Second one is Rescue. It is used for the material simulations. Third one is QTCAT, spin qubit device, and Matra, which is USA based company. It is used for the cloud based material simulations, and Fluxim it is used for the semiconductor material characterization and their simulations. They offer several softwares like Setfos, LAS, PEOS, many of these. But I will be discuss only at here Setfos tools and how we can use it. Our company provides many of the services like software distributor, training program, technical supports, and equipment. The equipment like microprobe station, solar cell, thin film, FET, gas sensor, transistor, memory star. Our company also have valuable customers IIT Madras, IIT Guwahati, IIT Dhanbad, IISER Kolkata. So many of the customers are present. For more detail about our company, you can check our website impulsetechnology.in. Who has not seen it my previous video, so you can check out the playlist. At here I have discussed about the Setfox usage, how we can use their tool, how we can use their parameters, and how we can fill this input, so you can get a lot of the information about. So in this video I will be discuss about optimization. It is a process or methodology for making some things as fully perfect, functional and effective as can be possible. So simple word we can say each tools the biggest goal to make process more efficient, logical, inexpensive. It can be a mathematical procedure such as finding the maximum of the function or minimum of the functions, and it is a process finding the best input variables among all possibility without explicitly evaluating each possibility. So in this optimization tools, we can set any of the layers as a parameter instructions and set as a target, so we can calculate all of the value with best results. So firstly I will be show how to we can use optimization tools. So we will be moved towards the Setfox tools. Click at right side, run as an administrator. I have already explained about the Setfox in my first video. You can easily get all of the information about Setfox and how we can use this software. In this video, we can show how to optimize the emissive layer thickness of the simple OLED structure in order to maximize the radiance. If you want to consider simple one of the examples, so you can choose OLED part example. It is an examples. So if you want these example parameters and if you want to optimize that, you can easily use. But for the better understandings, I will be create a new simulation file in here, so you can get a lot of the information about how we can use and how we can optimize their parameters. Click at plus I and you can add number of the layers and give each layer name one by one. Air, calcium, polymer, nickel. These are the extra layer you can remove easily. Click at the minus I. So these are the layer structures and you will be put at here thickness value. 125, 10 nm. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. Which layer are wavelength dependent and that you want to show their file, so you will be import refractive index .nk file formats. I have already told about this in my previous video. So you will be imported at here nickel.nk file formats, so you can simply import their file. For the aluminum, similarly you will be imported their file. You can import these two files, but we need to put the value at here refractive index constants. If you are not imported .nk file format or refractive index files, for the polymer it can be 1.8 their value, and thickness totally depend on you. If you want to change, you can easily change that here. We are here optimize emissive layer thickness, so we need to activate emission modules, and in the general tab enable emitter for the polymer, and we need to import at their file .pl photoluminescence file. At here it is supported .pl file format, and simply you can import that here, and unit it will be a probability. You can check at here the preview, x-axis and y-axis. Distribution consider at here delta, but need to put at here position 0.5. If you want to change the dipole orientation, you can see at here given isotropic, parallel, perpendicular, and the customs. At here emission intensity, quantum efficiency, conversion efficiency, and lifetimes. If you want to enable, you can do. At here the emission modes at given spectral, dissipation power analysis, mode analysis, shift as the wavelength 380 to 780 step you can consider at here. If you want to change the range, you can easily change at here. Wavelength 550 nm, emission angle 0 degree. If you want to set the spectral emission settings, you can easily set at here with the single click. We need to switch off any multivariable shift by pressing the shift button. If they are activated, we need to switch off these parameters. And optical environment of the radiating dipole change at each iteration. We are changing at here the geometry of the device. A dipole radiation means it is a form of the electromagnetic radiation emitted by changing in electrical dipole moments. We need to enable at here the conchings to consider the correct conching of the exciton at the electrode for the current structures as we vary of the thickness of the light emitting layer during optimization. We select force reset. You can see it here the mean wavelength, full spectral, fast spectral, but we need to consider at here the mean wavelength. The layer thickness of the polymer optimized to get maximal radiation. We need to activate the optimization modes. You can see at here the parameter. That parameter you want to extract at here given a lot of the parameters, and the three dots you can also see at here the opticals for the layer, polymer, aluminum, thickness, optical band gap for the emitter one, and their position, lifetime, quantum efficiency, dipole orientation, conversion efficiency, their spectrum for the optical emission angle, wavelength, in play wave vectors. At here we want to extract the polymer thickness, so you need to consider at here thickness polymer dot d unit nm. You will be put at here the value. It totally depend on you. If you want to change their value, you can easily change. You can simply see at here the indication maximum value is not defined, but we have already defined their maximum value. But if you click at here the target, you need to set the target value. A lot of the parameter is given at here. Target value, generally the layer thickness of the polymer optimized to get maximum radius. So we need to add here the select radius, but you can see at here the peak intensity, peak wavelength, a lot of the parameters are given. We are selecting at here the radiation. You can see it at here, a lot of the value also given. At here the minimum and maximums and their value. As we, starting of the my presentation part, I have already told about the minimum and maximum value in optimization parameters, how we can define. So in here it is given. So I am choosing at here maximum value. All the optimization parameters are set in here, but we can see at here the local search, global plus local search, error line span. So these different at each term have the different meanings. For the local search, you can simply use as if you want not too much long calculations. So you can easily click at the local search. But if you want to the global search, so it means the same results as before, but does not require specify the number of scan points for each parameter, generally faster than pre-scan method. But if you go with global plus local search, that's mean most reliable but most time consuming method to get your results, which will first run the global optimization algorithm followed by the local search. So you can simply click at here the local search. Local search can also be a meaning that things we are assume at the initial guess how much it is a right. So you can see that here the layer structures are completed. Emission setting also have done. Optimization settings we have already completed. Now you can simply give name of the tutorials and press the run button. You can see that here the optimized parameter value for the polymer, it is given at here. If you change at here the value and press the run button, you can see that here the different value. If you select the pre-scan methods, you can see at the value. Pre-scan generally mean it will be calculated lowest error value to get. In this value you can get the idea. If you change the thickness of the layer, so at the radiation penetration it continuously decrease at the entry of the layer, because absorption and scatter possibilities continuously increases. In here you can optimize multiple parameters, so it is a best effective way to get best results. Setfos can simultaneously optimize multiple parameters, so we need to navigate the optimization settings and select the parameters and the targets. So you can simply click at here the plus symbol and you can select at here the dipole position. You can also use alternate method to select the parameters. The polymers, go with the emitter 1, and you can simply click at here the position. So the similar alternate method you can use at here. Now you need to set at here the value pre-scan, and you can put at here log value 11. Dipole position you can consider 0 to 1. Minimum as a 0 and maximum you can select at here 1. Dipole radiation, as we have already told, it is an electromagnetic radiation emitted by a change in electrical dipole moment. When a electrical charge particle oscillates, it produces an electromagnetic wave. Then is referred to electrical dipole radiation. In here, we will be optimize the thickness of the polymer along with the location of the dipole at the same time. We have already set the dipole positions, as the radiance can have several local maximum as a function of these two parameters. We will be chosen at here screening value at the parameter specs. So it is a log value 25 and the 11. The similar value it can be scanned at here for the dipole position points. At here 11 for the dipole position points and 25 it is for the layer thickness points. So 11 into 25, that all parameter combination that can be scanned by Setfos tool. Now you need to set at here the targets. You have already set at here targets at the radius. At here the key figures, files and plots are given. So in here the key figures generally mean containing seller targets, and for the file at here the using target according to the corresponding results file name and column, and for the plot category and name in which data are displayed in the Setfos results. It can be alternate method. You can select at here and otherwise you can select in here. If you want to the CPU parameters, you can easily use this tab. At here the targets modes are given: default, steady states, transient, AC, and residuum types for the linear and logarithm if you want. Optimization methods, precision, maximum iteration also given at here. General settings given. In my next video, I will be show how we can use these parameters. If you are considering tandem solar cell, so you can activate that tab, so you can use at here, but we are not using at here because we are working on the emissive layer thickness variation according to the radius and dipole position. If you want to check more times the layer structures, if you do any mistakes, you can easily check at here, and otherwise you can give at here the name and then simply click at here play button. I have already run the simulation, so you can easily see at here the results. It is a key figure and the for the polymer and the dipole position. It is used for the thickness value and it is a dipole position. It is a optimization results. Optical key figures are given, error function, error landscapes, parameter evolutions. At here the results are given, color diagram, all the optical profiles you can check in here: exciton density, radiating dipole density, radiative rate profile, refractive index, spectral, absorption, reflectance, transmittance, emission parameters, and normalized emissions. So you can check out here all the results that you want. So I hope you can get a lot of the information about the optimization settings. And in here, if you have any query about these tutorials, you can ask me in the comment section, and you can also contact at the description box. Email are given. If you want to book a demo, you can go with the websites impulsetechnology.in. So I end at here my tutorial. Thank you very much.